Hey mathematicians, today we're going to look at some of the common sense behind inverse trig functions. Make sure that you've printed out your reference page that goes along with this video so that you can follow along. Hey, let's talk about inverse trig functions. In the box up here, I just have the notation reminding you that the -1 here indicates that this means sine inverse. And another name for sine inverse is arcsine. Same thing with cosine inverse, which is arc cosine. Tangent inverse is arctangent, etc. The -1 is not an exponent. It doesn't mean 1 over sine of x. Cosine to the -1 doesn't mean 1 over cosine of x, etc. All the -1 is there for is to tell you that we're talking about an inverse, not a power, it's an inverse. So just a kind of quick reminder about how trig inverses work. If I have sine of theta equal to x, where theta is an angle and x is the trig ratio of opposite over hypotenuse, the sides of the triangle, then if I take the sine inverse of each side of that equation, because sine inverse is the inverse of sine, they undo each other and I'm left with theta, the angle. And so it's saying that theta, the angle, is equal to the sine inverse of x, which was the trig ratio. So, for instance, if you're asked to find the sine inverse of root 3 over 2, remember root 3 over 2 is the trig ratio. So we're being asked to find the angle such that the sine of that angle gives us that trig ratio of root 3 over 2. So please remember, every trig function results in a trig ratio. The cosine of theta will give you some adjacent over hypotenuse. But every inverse trig function results in an angle. Just like here, we wanted sine inverse of root 3 over 2. What is the angle that gives us that value? Another thing that's kind of important. If you yourself are solving an equation, you're solving some problem that you're working through, and you decide, I need to introduce an inverse trig function here. I need to apply, for instance, cosine inverse. Then you need to find every single answer, every single angle within your given domain. There may be more than one possible answer. So for instance, in this particular problem, we're going to solve for x, and x is somewhere between negative and positive 2 pi. So the problem that we are looking at here is 2 times the cosine of x equals -1. Okay, divide by 2, now we know that cosine of x is supposed to be equal to -1/2. If I decide to apply cosine inverse to each side of the equation, cosine inverse over here gets rid of the cosine and I have x, and then cosine inverse over here of -1/2. So what I'm looking for is all the possible angles within this given domain such that the cosine of those angles gives me -1/2. And of course, it turns out there's 4 different solutions. Let's look at those. So on my unit circle, remember I'm looking for cosine, which is the x component. Cosine is the x component because it's adjacent over hypotenuse, adjacent being the lateral side or the x component side of each coordinate, and the hypotenuse of course is 1, so that's sort of a moot point. So I go through and go, where is my cosine -1/2? Oh, here we go, at 2 pi over 3. Right? It's always going to be over here in the negative x values. And if we go a little further around the circle, we find we also have cosine of -1/2 at 4 pi over 3. So between 0 and 2 pi, those are the 2 positive solutions, 2 pi over 3 and 4 pi over 3. Both give me a cosine of -1/2. Now we also had to go backwards into from 0 to -2 pi. So if we're going backwards, we're here like -pi over 6, -pi over 3, -pi over 2, right? All the way over to here. This is -pi over 3. This is -2 pi over 3. So that's one of the options. And then, of course, all the way around here to -3 pi over 3 and -4 pi over 3. Boom, there's the last answer. So that's why we list it out here. 4 different solutions because they all give us a cosine of -1/2. So that's one way of looking at cosine inverse or just inverse trig functions in general. But if you are given a problem and it says, find the inverse trig of this, you're not introducing the inverse trig function, it was just given to you, then you need to know that there's only one actual solution. And that solution comes from a specific range that you're given for each of the functions. So for instance, sine has a range from negative to positive pi over 2. cosine's range goes from 0 to pi. I want to show you why that makes sense. So for cosine, if I'm looking for a specific cosine, like in that last problem we were saying cosine, we want cosine inverse of -1/2, right? So if you look at all the cosine values, in the first quadrant here, all the cosine values are positive. And then in the second quadrant over here, all the cosine values are negative. So does it sort of make sense that from 0 to pi, you have all the different possible cosine output values that you could pick from? So if you have a positive cosine value, positive trig ratio, you're looking for an angle from here, and a negative cosine value, you're looking for an angle over here. However, for sine, you'll notice that all of the y values in quadrants 1 and 2, all the y values are positive along here. So it doesn't really make sense for us to be looking from 0 to pi for sine inverse. Instead, we're going to go back over here, back down from 0 down to -pi/2, because here we have all the negative sine values. So again, sine inverse, you're going to look for angles from -pi/2 to +pi/2. And for cosine inverse, you're only going from 0 to pi. Turns out that we also have similar ranges for arctangent and arccotangent. Since tangent is sine over cosine, so it involves both of them, you actually just lead with what the numerator is. So since tangent is sine over cosine, if you're looking at arctangent, you want to think about the same range as arcsine. So arctangent, you're again going to be going from negative to +pi/2. And then arccotangent, which doesn't come up that often, but if it does, remember cotangent is cosine over sine. So arccotangent has the same range as arccosine, from 0 to pi. And of course, I have that listed out here for you on the reference page. Okay. So on the back of that page, we've got a few examples to look at. So the first example looks fairly familiar. We're looking for the cosine inverse of -1/2. So this is the way the problem is given to us, and so the way it's written implies there's only one solution. We're not looking for all the different solutions. There's only one solution. It comes from that specific range for arccosine or cosine inverse. Right? And again, I just went through this. We looked at the unit circle, and the positive cosine values are from 0 to pi/2, and the negative cosine values were from pi/2 to pi. And again, cosine inverse of -1/2. Here's -1/2 from 0 to pi. That's the only one, and that's at 2pi/3. So our solution for this example is cosine inverse of -1/2, 2pi/3. Here's another one. We're looking for sine inverse of -√3/2. Remember, our range for arcsine is from -pi/2 to +pi/2. So I'm looking along here, and since I'm looking for -√3/2, it's not going to be up here. It's going to be down here, and look at that, -√3/2. So I have to go backwards. That's -pi/6. So -pi/3 is my solution here. -pi/3. And I just spoke about this, but for tangent, sine over cosine, so arctangent has the same range as its numerator as arcsine, so it's going to be from negative to +pi/2. Cotangent is cosine over sine, so arccotangent has the same range as arccosine, 0 to pi. So next, there's 6 examples for you to solve. Remember that since I'm giving you the problem that includes a trig inverse, there's going to only be one solution for you to find. So why don't you go ahead and pause the video and take some time to solve those problems, and then you can unpause and check to see how you did. So welcome back. You took some time to solve these 6 trig inverse problems. Let's take a look and see how you did. So we're looking for sine inverse of 1/2. Remember that we're looking between negative and positive pi/2, and sine is the y value of each coordinate. And nope, there you go. 1/2 goes with pi/6. So that solution is pi/6. What about tangent inverse of 0? I know that tangent has the same range as arcsine. Arctangent has the same range as arcsine. So I want to know, and tangent is sine over cosine. So, oh, look at this, 0 over 1. I know that tangent is going to be 0 at 0 radians. So arctangent of 0 is 0 radians. Arctangent of -1, well, I need to look where sine over cosine is equal to -1. That means the sine and the cosine values are going to be exactly the opposite of each other. They're going to be the same value, but one's positive and one's negative. Well, that happens here, and that happens over here. So which one is it? Remember, tangent has the same range as sine, so it's going to be from negative to positive pi over 2. And of course, my sine over cosine, my negative root 2 over 2 over positive root 2 over 2 is going to give me 1. And so I'm looking at negative pi over 4 is my solution for that problem. Cosine inverse of 0. Well, I know cosine is just basically the upper half of the circle, and cosine is the x value. So boom, that's going to be pi over 2. Okay, these are starting to get easier. Sine inverse of root 2 over 2. Well, I know all my sine values are positive over here. And root 2 over 2, that's 45 degrees, also known as pi over 4. And then finally, I want cosine inverse of negative root 2 over 2. And I remember cosine is the upper half of the circle. And I'm looking only over here at the negative cosine values. And of course, that's going to be 3 pi over 4. That gives me a cosine of negative root 2 over 2. So good job if you got those all right. The last thing that I want to talk about is how do you solve a problem if you have something that's not a common trig ratio? So the common angle values that we'll be using in trig are the multiples of pi over 6 and the multiples of pi over 4. So, root 2 over 2, root 3 over 2, a half, 0, 1, something like that. Is there anywhere on the circle where you see a trig ratio of 4/5? That's not one of our common trig ratios. So this problem looks kind of scary because like, what angle is it that gives me a sine of 4/5? I don't know. Well, it turns out the problem is not nearly as confusing as it looks. So this is asking for the cosine of the angle such that the sine of that angle is 4/5. Well, I'm going to basically name the angle. I want to name the angle theta. We're going to name the angle theta, and I'm going to put theta right here. So just draw yourself a triangle. You draw yourself a picture, and let's set it up so that the sine of that angle is 4/5. Well, sine is opposite over hypotenuse, so I'm going to put 4 and I'm going to put 5, right? So now I see that theta is sine inverse of 4/5, or sine of theta is 4/5. So I took the given information and I set up a problem that works for it. And then the question is, what's the cosine of that angle? Because remember, sine inverse is the angle. So really, I want the cosine of theta. So cosine is adjacent over hypotenuse. So I need to figure out what this side is here so I can set up that ratio. So I'm going to use the Pythagorean theorem, and I can set this equal to x. X squared plus 4 squared equals 5 squared. You probably already know the solution to this. So I have x squared plus 16. Oops, that should just be a 5, is 25. So x squared plus 4 squared is 5 squared. X squared plus 16 is 25. And of course, that means x squared is 9. So x is 3. And you probably knew that because of the Pythagorean triple, 3, 4, 5. Well, long story short, the cosine of that angle then is adjacent over hypotenuse, or 3/5. So anytime you see a trig ratio that does not look familiar, draw a picture. That's the best way for you to go. Thanks for watching the video.